All right, here we go. First lesson. Well, this is a little weird. How about we have McKinley start us off with a joke? Go ahead, McKinley. Tell us all a joke. Best joke ever, McKinley. Thank you much. All right, let's get out our homework. So the homework was on 9.2b. It was the second part of solving a system by substitution. All right, here's what I need you to do. I need you to hear the answers. I need you to check your answers to this. Pause the video after you check your answers, count up how many you got wrong, and then answer question number 1 on the Google Forms. And the question is, how many did you get wrong? So go ahead and pause the video, do the corrections, and then come back once you're done. All right, great. Here we go. Normal things. So the calendar, this week we're going to do 9.4, 9.5. They're both on solved by elimination. We will do a chapter review, no chapter test. And then we'll jump right into chapter 10, and then we are done for the week. Here's your homework for tonight. Write this down, please. It will also be at the end as well, too. And just remember, since this is a video, you can pause. You can rewind if I talk too fast. And it should be just a little bit quicker than a normal class. If you have any questions during or after the class, make sure you email me, and I'll get you an answer as soon as I can. I will be watching my computer all during the day. All right, so 9.4. This is one of my more favorite classes of the year, so solve a system by elimination. And I found that most students like this technique. Out of the 3 that we learned, they like this one the best. 2 objectives: solve a system elimination by adding, and solve a system using elimination by subtracting. Recall, what we're really doing here is I'm going to give you 2 linear equations. You're trying to find where they intersect, where their intersection point is. Remember, we have 3 basic techniques. The first one is graph. Well, 4 if you count your graphing calculator. But the first technique is we just graph on the coordinate plane the two equations, and we're looking for the point where they intersect. And you notice right here they intersect. And when this works by graphing, it works really well. It is convenient. Of course, remember you have to have both equations in the form of y equals mx plus b. All right. So we've already covered graph. We did that for 2 days. The one drawback of graphing, as you can see right here, is that when the intersection point happens at a non-lattice point, you can notice right here it's a non-lattice point, then you got to estimate. Now, of course, with a graphing calculator, it will always tell you the right answer. But when you're graphing this by hand, it does not do this. So our second technique, when the graphing fails, and I don't want to say it's the second technique, you graph it first, find out it fails, and then you use substitution. Remember what I said was when one of the 2 linear equations is already solved for one of the variable, the substitution method is our number 1 go-to thing to do. If you solve by graphing and you find out it's not at a lattice point, substitution is also another good choice. The only drawback of substitution is that it's complicated. Look at all that stuff. And this is what you did for homework for the last 2 nights. It will absolutely get you to the right answer, 2.3, 1.6, but boy, it involves a lot of algebra. Sorry, Isaiah, the arrows aren't underneath. Okay, but you guys should now be experts at solving by substitution. The third technique is called elimination. Elimination, we use it when both equations are in standard form. Remember, if we're solving by graphing or by substitution, for graphing, both equations have to be in the form of y equals mx plus b, or you need to put them in that way. For substitution, we use it when one of the equations is solved for y or for x. But if both equations are in standard form, I'll show you an example here in a second, then you'd have to do a lot of work to either graph or to substitute. So we have this third technique. We use it specifically when both equations are the form or in standard form. So I need you to stay with me. Trust me, you're going to like this. Well, you might not like that, but you will like this technique. Yummy. Solve a system by elimination. So clear your minds and let me talk you through how this thing works. If we had one equation and we had a second different equation, what could we do with those two equations? Turns out we can do a lot, and over the next 2 days you can explore this. Now remember, solve a system equation, we do have two equations. Before we graphed or we did this thing called substitute, I'm going to teach you a third thing. If you have two equations, let's explore what else you could do. Well, turns out you can actually subtract those two equations. Literally, you could stack the two equations and you could subtract them. Well, the left side would turn into A minus C, and the right side would turn into B minus D. Well, that doesn't really seem that interesting. Let's throw some numbers into two equations. This is one of an infinite number of examples. But here's an equation. We know it's an equation because the left side equals the right side. Here's a second different equation. The left side equals the right side. And if we were to subtract these two equations, let's see. 6 minus 2 is 4. 3 minus 1 is 2. 9 minus 3 is 6. And if you start with two equations that are true, this doesn't work if one of them is false. If we start with two equations that are true equations, you wind up with a third equation that's true. So it turns out you are allowed to subtract two equations because the left side still equals the right side. All right, so if you can subtract, you would think you should be able to add, and it turns out you can. This would turn into A plus C, B plus D. Notice what I'm doing. I'm stacking the two equations, line up the equal signs. And then just simply add top to bottom, top to bottom. Over here, 6 plus 2 is 8, 3 plus 1 is 4, 9 plus 3 is 12. So we wind up with 8 plus 4, which we still wind up with a true equal statement. This only works if both equations are true. Okay? All right, so we're going to use those two basic rules, the fact that we can add or subtract any two equations. Right? And it turns out this is going to help us solve a system of equations. So let's see how that works. All right, so here are two examples of when you would want to use solve by elimination. I've got both equations, this one right here and this one right here. Both equations are in standard form. And if we were to solve either one of them by graphing, we'd have to solve for y. We get this ugly fraction, a horrible y-intercept. Over here, the same thing. If we were to solve for y, we would get, well, this one's not too bad, but still the y-intercept, 48 divided by 6 is 8. Well, I guess this one's a good one, this one's not so good. But we still have to do a lot of work. Turns out that solve by elimination will require huge steps, and they're pretty easy. All right, so what's the basic process? Our goal, since it's called elimination, our goal is to eliminate one of the variables, either the x or the y or the a or the b, depending upon what the two variables are. So it's called elimination because one of the variables we're going to be able to do this thing, and it eliminates one of them, and we simply solve for the variable that's left. So I'm going to do one. If we were in class and I handed you out the guided note sheet, you'd write this down in box number 1. So I need you to write this down on a piece of paper. Pause the video if you need to pause the video. But I'm going to give you 4 steps. Write down the 4 steps, and then I'll do one, and then you'll follow along with the steps. So here's the 4 steps I want you to write down. Step 1 says stack the equations. Step 2, add or subtract. So you got to make a choice of adding or subtracting. Step 3, solve for a variable. Step 4, substitute the value into either equation and solve. So pause the video for a moment, write down the 4 steps, and then come back and we'll solve one. Okay, let's solve them. All right, step number 1 says stack the equations. So you're going to take your 2 equations and you're literally going to stack them, one above the other. Now, it's important that when you stack them, you line up the x's, you line up the y's, you line up the equal sign, and you line up the constants. Now, if your equations are not in standard form, to use this technique, solved by elimination, they both need to be in standard form, or they both need to be in the same form so that when you stack them, everything lines up. You could theoretically use this if both equations are in the form of y equals mx plus b. But if they're both in the form of y equals m plus b, you might as well use substitution or even potentially graphing them. Okay, so step number 1, stack the equations, done. Step number 2 says add or subtract. Okay. The first thing we're going to do is we're going to add. All right, and let me explain why I know this one's an adding one. We'll check out the x's. If we were to add the x's, 5x plus 3x, we get 8x. We certainly didn't eliminate the x's. But look what will happen when we add these two. I've got a positive 6y and a negative 6y. If we add these two, we get 0. Like 6y minus 6y is 0, or conversely, negative 6y plus 6y, we still get 0. We add these two, a 48 and a negative 32, and we get 16. So notice that when I add these two equations, one of the variables, in this case the the y's, it goes away. We've eliminated it. So therefore we get 8x equals 16, which we can easily solve and get to x equals 2. And in fact, this step right here, the adding step, eliminated the y values. That's hence the term solved by elimination. Okay, step number 3 says solve the equation. So we simply take 8x plus 16, solve it. And then we do the same technique that we did for substitution. We take the fact that we just solved and we found that x is equal to 2, and we go back to either equation, the first one or the second one. It doesn't make a difference. You can be smart and pick the one that has the fewer negatives, so Landon will make fewest mistakes. I personally would probably choose the second equation, but you can choose either equation. As long as you don't make a mistake, you'll get the right answer. So I'm going to choose this one right here, just fewer negatives. And now I'm going to substitute x equals 2 for the x value, and then solve for y. That gives me a 6. Subtract 6 from both sides, divide by 6, and we get y equals 7. Now, if that was too fast for you, go ahead and rewind, listen to my explanation, pause for a second, look over the calculations, and if you truly have an issue, send me an email. I'll try to help you with it. Okay? All right. Remember, the final answer is in the form of a point, because remember, it's basically where do the two lines intersect? And they intersect at 2, 7. Remember, it goes x, y, so 2, 7. So the final answer of all this is 2, 7. And I just want you to notice that, okay, it looks like we did a lot of work, but we clearly didn't do as much work as substitution. In fact, all we truly did was just simply add 2 equations, and the rest was the easy part of the algebra steps. Okay, that's why most students choose this as their favorite technique. All right, one more example. Stack the 2 equations. Notice if we add, well, that's going to give me negative 6y. That doesn't eliminate the y's. But 3x minus 3x does eliminate. So when we add or subtract, the x's will be eliminated through addition. Okay? So negative 3x plus 3x or 3x minus 3x, however you want to think of the addition, it eliminates it. We get 0 for the x values. The rest, we simply solve for y. Therefore, y equals negative 2. I'm solving for the variable. And then the last step is I take this value right here, y equals negative 2, and I substitute it to either equation. And this one has 2 negatives. This one only has 1. I mean, it doesn't truly make a difference which one you choose, but I'll typically choose the one with the fewest negatives or the smallest numbers, and that way I have a better chance of not making a silly mistake. So I'm going to choose the second one, but I am allowed to substitute it in the first one if I so desire. So I'm going to choose the second equation. I'm going to let y be the value negative 2 and simply solve the equation now for x. Negative times a negative is a positive. Subtract 8 from both sides. Divide both sides by 3, and we get x equals negative 1. So the final answer, remember, is x comma y. So negative 1 comma negative 2 is the answer. Once again, if that was too fast, rewind, listen to it again, and if you truly have an issue, email me with a question. You guys ready to do one together? Okay, let's do one together. All right, so this is box 2. I first need you to just simply write down the 2 equations, just so you have that. Clean sheet, somewhere nice and neat. Okay, read what you had for step 1. Step 1 says stack the equations. So we stack the equations. Notice it doesn't matter how I stack them. If I wanted to stack this one on top of that one, that's how I do too. And this is also typically what I do. If the teacher writes the 2 equations left and right, I'll just simply take the second one and stack it underneath the first one. Remember, this technique requires things to be lined up. So if one of the equations is in the form of y equals mx plus b, slope-intercept form, and the other one's in standard form, you can't use this technique unless you both are in the same form. So if one is in slope-intercept form and one is in standard form, I'd probably do substitution. It would be just as quick. But if they're both in standard form, this is the quickest technique, and it is pretty easy. So we stack the 2 equations. Notice this is going to give me 8x, and 5y minus 5y would give me 0y. In other words, I would eliminate the zeros when I added these two. Therefore, x is equal to 1. I take this value, x equals 1. I substitute it into either equation, whichever one. Let's see, this one's all positives, so I'll choose this one. Remember, I'm not claiming you have to. We could easily substitute it into this one. We'll get the same answer. I chose this one because there's no negatives involved. 1 times 2 is 2. Subtract 2 from both sides. Divide both sides by 5. And we get y is equal to 1. So the final answer, xy, 1, 1. Okay? If you need to rewind this, watch this again. If you need to rewind, watch all 3 examples, do that. But let's move on and let's try to do one by ourselves. This one's blue. Let's do it one more together. One more together. All right, here we go. One more together. Okay, step number 1, stack the equations. Step number 2, add. That gives me 7x. That's going to give me 0. That's going to give me 14. Notice the y's got eliminated. Solve this equation. X equals 2. Take this, substitute it into either one. Hey, they're all positive. I'll choose this one. Okay. Substitute in x value 2 for 2. I'm sorry, substitute for the x, the value 2. 2 times 2 is 4. Subtract 4 from both sides. Divide by 2. And I get the final answer, 2, 3. Feeling comfortable? Got the idea? If not, rewind, watch the 3 examples again. All right, here's what I need you to do. Box 4. I need you to solve this system of equation by elimination. Use the technique I just shown you. Then go to the Google Forms. I'm not going to show you the answer yet. I want you to throw in the answer. You'll see the question states for box number 4, what is the answer? So do the whole thing all by yourself. Pause the video, and then go to the Google Forms. Type in the answer, and then hit the play button and let's see if you got it right. Okay, so pause the video. All right, you confident you got it right? Let's see. So solve by elimination. Let's see. They're already stacked, so all I got to do is add. So if I add, 4 minus 3 is 1, in other words, x. Negative 8 plus 16 is positive 8. Be careful with those positives and negatives. Hey, this one doesn't require any steps. 1 step and we're done. We just needed to add. X equals 8. All right, here's my 2 equations. Well, they both have, well, this one has 2 negatives. This only has 1. I'm going to choose the second equation. If you're going to make a mistake, it's typically when you're transposing or recopying the equation and throwing in your values, and you simply drop a negative. So for those of you that are really sloppy, just be really careful when you write down the equations. Check it twice. So I'm going to substitute 8 in for x for this equation, the second one right here. Substitute 8 in for x. That's going to give me negative 24. Add 24 to both sides. 24 and 16 is 40. Therefore, y equals 4. So final answer, see if you got it right, 8, 4. Good job for those that got it right. For those of you who didn't, try to identify your mistakes. Typically, it's either you wrote the equation wrong, or you dropped a negative, or you had a silly math mistake type thing. If you aren't confident in the technique, I would rewind this and watch it again as many times as it takes until you're confident. Okay? All right. So we just did solve a system by adding. Let's do one by subtraction. So what about subtraction? Yeah, let's do one for subtraction. What would that look like? Why would we have to subtract instead of add? So here's 2 equations stacked. Well, let's see what would happen if we added them. 2 plus 2 is 4. Didn't eliminate. 3 plus negative 6 is negative 3. Didn't eliminate. So this one would not eliminate anything if I added them. However, think about if I subtracted. If I subtracted, 2 minus 2 is 0. It would eliminate the x's. So the times that you want to subtract are when these 2 numbers right here are exactly the same. I'm going to go back to the previous. I'm going to go back to a previous one and notice that, or look back, rewind the video to the previous one, and you will notice that you don't get the same thing. You get a positive and a negative, and those are the ones that you add. But when both sides are the same, this is the one that you're actually going to subtract. This is the one that you're actually going to subtract. Okay. So this is the one that we're going to add. Now be careful when, I'm sorry, I said add. This is the one you're going to subtract. So be careful when you subtract. When you subtract, remember subtraction is the same as adding the opposite. Adding the opposite. So when you add the opposite, that means I got to do the opposite of all of these numbers. So this is no longer a 2. Remember, subtraction the same as adding the opposite. So all I'm going to do is change all the signs. This positive 2 now becomes negative. This negative 6 now becomes positive, and this negative 8 becomes positive. In other words, I swapped all the signs. Okay? Now I can easily add these two together. Add them together. Add them together. Okay. So let's add them. 2 minus 2 is 0. 3 plus 6 is 9. 10 plus 8 is 18. Okay, we eliminated the x values. Therefore, it's a simple thing now to solve for y. We get y is equal to 2. Okay? All right, let's see. Which one do I want to substitute it back into? The first one's all positive, so I'll choose that one. So I'm going to let y be the value 2 in the first equation right here. So y is going to equal 2 in that first equation. So 3 times 2 is 6. Subtract 6 from both sides. Divide by 2, and we get x equals 2. So final answer, 2, 2. 2, 2. Let's do another one. All right. Here's your two equations. Let's stack them. Notice the 2 is in the first equation for x. 2 is the coefficient in the first equation for x. 2 is the coefficient on the second equation. If the signs are the same, you're going to subtract. If the signs are opposite, 2 and a negative 2, you add. All right, so when the signs are the same, you're going to subtract the bottom equation. And subtracting is the same as adding the opposite. So what are you going to do? You're going to change all the signs of the second one because you're subtracting. So this 2 now becomes negative 2. This 3 now becomes negative 3. This 6 becomes negative 6. Now notice, by the magic of PowerPoint, I did that very easy. Be careful when you are doing it. Scribbling through, scratching, even erasing sometimes. Sometimes it just helps simply to rewrite the two equations rather than trying to erase and make a plus a negative. Okay, once you have them stacked, you've changed all the second equation signs, you add. 2x minus 2x is 0, 5y minus 3y is 2y, 10 minus 6 is 4, therefore y equals 2. Take that value, y equals 2. We're going to substitute it into either equations. Now, they're all positives, so it doesn't really matter which one I pick. I'll choose the one with the smaller values here. Y is the value 2 now. 3 times 2 is 6. Subtract 6 from both sides. Divide by 2. We get x equals 0. So the final answer, xy, we get 0, 2. You get it? Remember, subtraction is when you stack them, both numbers have the same coefficients. Adding is when one is positive and one is negative. All right, let's do one together. Write down the two equations and stack them. If you talk too fast, pause the video, get caught up. So I'm going to stack the two equations. Equation 1, equation 2. Notice when I stack them, I got 2 positive 5s. So I know I want to subtract. When you subtract, the second equation, all the signs were changed. Negative becomes positive, positive becomes negative, positive becomes negative. Okay? So that's what happens. Okay. Now when we add, 6 plus 3 is 9. That turns to 0. 39 minus 21, 18. Therefore, x equals 2. Substitute it. Well, these are kind of big numbers here. Doesn't really matter which one you choose. I'm going to choose even though these numbers are really big, I'm going to choose that one because everything's positive. I'm going to let x be the value 2. 6 times 2 is 12. Subtract 12 from both sides. It gives me a 27. Oh, ugly, ugly, ugly. Leave your answer as a fraction. Don't change it to a decimal. So therefore, y equals 27/5. That is the answer. Okay, be comfortable with that answer. Notice this is absolutely one of the ones that we would not be able to do by graphing unless we had a graphing calculator. So x comma y, 2 comma 27/5. Sorry. There's your answer. Feeling confident for subtraction? Okay. Try to do this one all by yourself. Same thing. Pause the video. Get to the answer. Type your answer into the Google Forms. It'll say what's the answer to the system of equations in box 6. So type your answer in and then unpause the video and watch me run through and see if you got the answer correct. All right, let's see if you got the answer correct. Stack the two equations. Notice the 10s are both the same, so we're going to subtract. We're going to change all the signs of the second equation because we're subtracting. So 10 would be negative 10, negative 5 would be positive 5, negative 4 would be positive 4. So I changed all the signs. Some people will do, as soon as they see that there's an 10x here and 10x here, when they stack them, they'll go ahead and change all the signs of the second equation when they write it stacked. All right, let's add 10x minus 10x is 0. That gives me an 8y. 12 plus 4 is 16. Divide both sides by 8. Y equals 2. I got two negatives here. Don't like that one. I'm going to substitute y value for the first equation right there. It says let y be the value 2. 3 times 2 is 6. Subtract 6 from both sides. Divide both sides by 10, and we get, well, we got to reduce the fraction. We get 3/5. So the final answer, x value 3/5, that's 6/10 reduced, comma 2. Did you get the right answer? All right, for those of you who did, good job. For those of you who didn't, see if you can identify your mistake. If it's a silly mistake, don't worry about it. Try not to make it next time. Okay, so let's see. So what's the obvious question? Well, what happens when you stack the equations and none of the numbers are the same, either positive, negative, or the same? Well, that'll be tomorrow's class. Tomorrow I'll tell you how to deal with this one, and it turns out it's pretty simple. One little tiny step. So tomorrow, if today doesn't go too well, hopefully the second class tomorrow, we'll get some practice, and this method will sink into your knowledge bank, and you'll be able to do it. So don't get hung up too much. If you're like, oh, I'm a little shaky on this, we'll get more practice on it tomorrow. But remember, it is a video. You can watch this as many times as you want to as well. All right, I guess we did it. We finished. Your homework tonight, once again, is right here. You can go ahead and pause the video, write that down if you didn't write it down, and just remember, while you're doing your homework, if you have any questions, don't hesitate to ask me a question, and I'll through email, and I'll get you those answers. So, guys, have a great day, and I will see you tomorrow.